Okay, then let's categorize the molecules by symmetry. So based on these 5 operations, we can understand what kind of symmetry each molecule has. Okay, and for example, it's a little bit confusing, but here are some of the category names. But also, for example, C1 or C2 as are the operation names, rotation operation. This is a little bit confusing, but be aware that if it's we're talking about the category name or operation name. Okay. The first one is C1. C1 symmetry is the molecule only has an E symmetry, which is very kind of unsymmetrical molecule. For example, CFClBr, which could be probably impossible to synthesize, I suppose. There's no symmetry for this molecule. Okay. And then the next one is Ci. In this category, you have E and I operation. So you have only E. Of course, you have E, but the I, only the inversion symmetry you have. So you can think like this based on the here inversion center. Each molecules are going to after symmetrical operation, it's going to overlap. So this is still quite complicated unsymmetrical molecule. And then in the case of C2, now you have not only E but also C2 symmetrical operation is possible. Here's a thing H2O2, right? And this one type of molecules. So you have a symmetrical axis in here, and you have only the C2 symmetry, meaning the 180-degree rotation. You could overlap the molecule again. So this is a C2. And like this, so in each category name, you have each molecule has several symmetrical operations. For example, C2V, you need to have a C2 and there's two sigma V operation, 2 mirror operation. In the case of C3B, you have C3 operation and also 3 sigma V operations. And in a C2H, you need to have E, C2, and sigma H. And one of the example is given in the figure 7.9, and which is here. So this molecule has the molecular access purpose here, and you have a C2 operation in the computer screen. So rotation. No, that's actually mistaken. Okay. So in this case, axis is something like this, right? So 180-degree rotation is going to this molecule overlap again, and also you have the mirror operation perpendicular to the molecular axis. and you have a sigma H operation. In this case, you can categorize this molecule into a C2H. Okay, and also more complicated and more, if going, you can see that it's going down more symmetrical molecules. In a case of DN, meaning that you have N C2 operation axis vertical to the principal axis. So you have it's kind of like several axes, several asymmetrical axes in the molecules. One of the complicated molecules, like in the group name D2H, you have E and C2 and 2 times C2, and also sigma H operation. So let's see the example here at 710, like this. So in single molecules, you have you can take the molecular axis is here, but also vertical to this molecular axis, you have two C2 operation could be possible, and also you have a sigma H operation, right? So this is this is a D2H operation, like this. So the key point is, after checking if each molecule has the symmetric operation or not, you can categorize each molecule into the different category group. Okay,